I'm going to turn this microphone over to you.
Okay, folks, let's go ahead. If you haven't grabbed a seat yet, that looks like everybody has. Okay, last year we had Jeremy for the first time present to us, and we're hoping that he'll lock us in each year, but you be the judge of that. Your applause at the end might just get me to ask him again. I'm fairly certain it will. The pictures that you saw at the beginning here, that was of my band playing out at the Branchville Observatory. And then he posted some of them online. They're some of the best pictures I've seen of our band yet. I'm just surprised that my mug didn't break that very expensive camera. So that was a lot of fun that night, trying to hide from it. So, I can't remember which department it is that you work at.
Natural Resources.
Jeremy Bauer is at Natural Resources, East Campus, UNL. And I think he tootled under, what was the last guy's name that used to come down here?
Oh, Ken Dewey.
Ken Dewey, Dr. Dewey. I'm sorry, my brain's scattered up here tonight. I had to do a lot of quick stuff to get things going. But my understanding is, and he's been boasting about it for a while, that this presentation is going to have you on the edge of your seat. So I've been looking forward to it. I can't wait to see it. So without further ado, Mr. Bauer, the floor is yours.
No pressure there, right? Well, good evening, everyone. How's everyone doing?
Good.
So this is going to be the third time I presented. The first time was in 2021 when we did the whole online kind of hybrid type thing. The second one was last year. And now we come to the trilogy. Because everyone knows the sequel and the sequel to the sequel is better than the original. Something like that. So, we'll go through standard setup like I've done in the past, do a quick introduction, a little bit into how to stay as safe as possible while you are out there storm spotting. I'm going to go through a couple setups from last year. I'm going to expand a little bit on some of those basic storm spotting concepts. When you say the name Hallam, everyone knows what you're referring to. We are now approaching the 20th anniversary of Hallam. However, what I'm going to propose to you is what if. Just keep that in mind here once we get to that. Go through some of the best images, non-weather related. And of course, disclaimer, this is not intended to be a substitute for an NWS Storm Spotter talk, so please attend the Storm Spotter talk this Saturday. All right. Oh, the face that only mother can love, or my wife. This has been a passion of mine for a very, very long time. And putting this presentation together, I was trying to figure out what approach could I take. Because, you know, the one from 2 years ago was approaching the unapproachable, easy for me to say. And then we went into some non-ideal environments. So this trilogy that I speak of, what are we actually going to focus on? We're going to focus on what is the actual secrets to staying safe while storm spotting. Keys are knowing where you're at, knowing what direction and what speed that storm is moving, and when necessary, having an escape route, knowing when to get out of Dodge.
At least one.
But at this point, also having the knowledge that any storm environment should be considered dangerous to not only life, but property. Situational awareness is the number one thing, and it doesn't matter if you're a spotter a storm chaser, just a general member of the public, you know that lack of situational awareness could get you a little bit in trouble. So let's go to the most extreme example possible. Now, I'm going to need a favor from the audience. Someone volunteer if you've got a stopwatch on your mobile device, watch, whatever. I'm going to need a favor from you, so do I have to volunteer? Not everyone at once. Okay. So what I'm going to do, when I say go, start the timer. That is, of course, the Joplin tornado. That tornado like movies, a cliffhanger. Technology is great when it works. All right, that was the end of the film anyway, so go to the next slide. All right, what was the time on that?
37.22 seconds.
So 37 seconds, you went from a single vortex tornado to bona fide wedge in 37 seconds. Raise your hand if you'd be prepared for that. Not everyone at once. Yeah. I know that's the most extreme example, but it is to implant it in your head that situational awareness is key above everything else, except for maybe your eyesight, which goes into situational awareness. So if you ever think that a storm is tame and the situation's under control, just remember that video. That tornado is the first tornado to cause over 100 fatalities in the United States since 1953. So, how can you stay safe? Knowing where you're at and where the storm is at. We had some pretty good response last year when I was showing a bunch of radar images, this app called Radar Scope. It's great. It can tell you exactly where you're at in relation to the storm. It'll show you warnings. And the resolution is great enough that if there is a hook, which right there that looks like that could be definitely a tornado in progress, that you know exactly what's going on. Also, another neat little thing is that it will also tell you how far you are from the storm. This little up here, you can turn this on. Here we're at, right here in this blue circle, and then you can draw it out to the storm so you know that storm is 23 miles away. So when you look at this, and you're trying to guess, well, how far is that from me? Well, now I know for sure that storm is 23 miles away. Isn't that really important when you're relaying reports? Knowing the distance, where you're at in relation to the storm? You can get that exactly accurate with that particular app. But wait, there's more. Rest in peace, Bill Mays. Anyway. You can also tell where this storm is moving. It will tell you these little lines right here. When you click on that, that'll tell you the estimated time that storm's going to arrive at that particular location. So if you've ever been interested in a particular radar app, whether it just be for your family or being out there while spotting, radar scope is probably going to be one of the best things to use. That particular storm, right here, that is us right there. Little hook, that is that. This is near Atlantic, Iowa, last summer. Rain and hail over here, where you expect it. Inflow, Beaver's tail, coming in here at the mid-levels. This is a very, very good indicator that this storm is intensifying because it's pulling all this warm, moist air into the main updraft. Main updraft right here. You notice it's tilting a little bit. That's how you know that there's really good shear in the environment. Wind shear. There's your wall cloud. More classic looking supercell, which is years back near Oregon, Missouri. This particular storm dropped 5-inch hailstones. Luckily, we didn't have the damaged windshield, thank goodness. Same type of concept. Main updraft, and your wall cloud will always be underneath that main updraft. Same thing. Rainfall over here, have you ever watched a video online, whether it be a spotter or maybe a chaser, and they use the word the vault? What they're talking about is this main core of rain and hail falling just to the east, northeast of that wall cloud. So if you ever hear that word, vault, that's what it's being referred to. Same thing, inflow Beaver's tail right here, mid-level, and there's your anvil right there sticking out, so that's where you can see my modest clouds. Those were those peeking out from. High precipitation supercell, everyone's favorite. Not. Here we are, looking back towards this. There's a little appendage here. Problem is, as we look, I mentioned this last year, got this little horseshoe developing. And a lot of times that will be an indicator that a tornado could be occurring or ready to occur besides seeing a wall cloud. So if you start seeing this, and you see this kind of wrapping around, that's basically what's happening is this mesocyclone is starting to wrap up, and if there is a tornado, it will always occur on the north side of that horseshoe. So if you see this type of structure, it's going to occur on the north side of that particular structure right there. Now, if you're right here, what would that look like to you? Look like this. You're not going to be able to see anything because the tornado is embedded in rain. This particular storm, this mesocyclone right in here, from edge to edge, this is probably about 5 miles across. Now, the tornado would not be 5 miles across, probably, but it could be anywhere in this rain and hail. So if you see this, you're not going to be able to see much of what's going on until it's right on top of you. Let's go over a couple case studies. May 12th. Interesting event. If you ever want to know what's going on, whether it be next day or a couple days out, go to the Storm Prediction Center. There's the website right there. Now, if you look on the Storm Prediction Center right now, you'll notice that I think it's day 6 right now, there is actually they're actually enclosing our area in a area that they're looking at for potential severe weather. I believe we're looking at Monday. So something to kind of keep your eyes on here. But basically this outlook for May 12th, there were a couple key things. Now you may not understand everything that's going on or what's being said in there, but there's a couple key points. Warm front across the Kansas-Nebraska border. That's important to know. Warm fronts in this part of the country are notorious for having the supercells and the tornadic supercells. Mentioned early afternoon initiation. Early afternoon to me probably means between 2 and 4 o'clock. Most of the time in this part of the country, your storms are developing about 5 or 6 o'clock. So to me, early afternoon initiation here in eastern Nebraska, probably between 2 and 4. Remember this acronym SLIM, the ingredients for severe weather. It's referring to shear, lift, instability, and moisture. Shear is just your winds blowing at different altitudes, blowing in different directions. You have you have not only directional shear, different directions, but you also have speed shear. So you have different winds at different altitudes. That's your shear, your lift, that's your warm front right there to get those storms going. Instability, you've ever heard the word CAPE. You'll hear that again on Saturday. Convective available potential energy. All those things, and then your moisture, your dew point, so you have everything. And so storms will be in the region of moderate CAPE, back to low-level winds, increasing wind speeds with height. Well, we know increasing wind speeds with height, that's your shear. Back to low-level winds, when you talk about a backed wind, they're talking about a wind out of the southeast. Why is a surface wind out of the southeast important? Basically, that means the winds are going into the storms and they're not being impeded. So it's serving as kind of like a fuel source for those storms. It's dragging all that energy and all that moisture into those storms. So when they start talking about backed low-level winds, your warning antennas should be going up there. Now, interestingly enough, they're talking about storms tracking northward, which is interesting because when you read the Omaha AFD, which I highly recommend, especially when you start getting closer to days where you may be potentially deployed, start reading this AFD because there's a lot of information in there. One thing that's going to be giving you a little bit more detailed analysis of that day is that it will actually pretty much tell you that a significant severe weather event is potential that day with all hazards possible. When they talk about all hazards possible, that means everything you can think of. Tornadoes, large hail, damaging winds, flash flooding, all those hazards. Now, I've been blessed in my life with many things that I'm good at. Drawing is not one of them. So this is my attempt at drawing a weather map. This is why you'll never see this ugly mug on TV. Low pressure right here, warm front right here, cold front right here, and that's a sorry excuse looking for a cold front, but whatever. All right, surface map. You got winds coming out of the southeast here, you got a little wind barb here, you see the spool line, that's 10 knots. Half a barb there, that's 5 knots. And then when you start adding them together like this, full one, half one, that's 15. And then whatever direction this barb is going, that's telling you where the wind is blowing from. So all your winds here, south of the front, south, kind of turning southeasterly as you kind of go up towards the border. Look how juicy this air is. 70-degree temperature with a 70-degree dew point. That is what we call moist. I will have you know that is the only time I will use the word moist tonight. You're allowed to laugh. This is supposed to be fun and educational. Stand up was not in my forte. Anyway. So, what you have here is basically this low pressure going to be moving closer and closer. Well, as this turns, it's going to move these winds more out of from the southeast to south. So that means your storms are going to be moving north. So, another reason to pay attention to the Storm Prediction Center is they will issue what's called mesoscale discussions. This is usually a prelude to a watch. It will tell you what the likelihood of a watch is. Here it's 80%, so you're pretty much guaranteed severe thunderstorm or tornado watch will be issued sometime in the next few hours. Key thing on this one, all you need to kind of look at, all severe weather hazards, okay, we knew that. Surface-based cumulus across central and eastern Nebraska has shown signs of vertical development. I'll show you an example here in a second. Should expect discrete cells to grow rapidly and reach severe criteria. Discrete is the key term there. Anytime you're going to have a significant tornado threat, it's going to be discrete cells, usually. Usually that's the case. Now, I'm not going to say the word, you read it for yourself. Anyway, wind shear, severe weather sky right here. Notice something about these clouds. A lot of moisture, but notice how they're tilted as you go up. That's how you know you've got significant shear. So even though the skies are blue and all this, and it looks fantastic, this is your severe weather sky. Because in about 2 to 3 hours, you're probably going to have storms at your doorstep. So just kind of keep that in mind. When you start seeing stuff like this, it's about to go down. Sure enough, about 2 hours after I took that photo, this started happening. This is pretty explosive development. It's right here. Always fans into the anvil. This is just a few minutes later. Rain, hail, over here. It's got an isolated base. Starting to lower a little bit. It's still ingesting. You notice our winds here are blowing into it? That's your inflow. If you've got wind going into the storm, winds at your back, that means it's ingesting that air, warm air into it. That means it's ramping up. If you've got wind in your face, it's outflow dominant. That means all the rain and hail are cooling from that downdraft, and the storm may be starting to die off. A few minutes later, the storm looks pretty low topped, and that's what ended up happening on this day. We had a bunch of low top thunderstorms, but the main updraft's right here because you can see this base starting to develop. Again, rain area over here, got an inflow tail going in, but look how fast this updraft's going. Look at that. That's Cape. When you got a lot of energy in the mid to upper atmosphere, that's that Cape coming into play right there. Here we are, the storm, a few minutes later, almost looking due north. That's what happened. It wasn't here, but you had some pretty significant tornadoes that day. But the other thing is, look at this large tornado, and that's the top of the storm. That is probably maybe 30,000 feet. This is what we would call, there's some research out there. These are what they're called mini supercells or cold core setup. Yeah, those can be very deceiving days. So, we had fast storm motion, abnormal storm motion, south to north, but we had really abundant moisture. If we had a little bit drier air, like they had out near Oakland and all that, we would have had better view of the storms. But what if the cap had been a bit stronger that day? And the cap is what we refer to as sin. So you have sin and you have cape. Sin is basically the lid. It's kind of like that pressure cooker. You put the lid on it, it's keeping all that in there. Well, you take the lid off, raises up, right? Well, that's the cap. Imagine this had been occurring an hour later or 30 or 50 miles further to the south. So this is where we come into the what if. So we're approaching the 20th anniversary of Helen. F4, then it was the Fugitive scale, now it's the enhanced Fugitive scale. F4 tornado, 2.5 miles wide. But I'm going to propose something to you that may have never been proposed to you before. Do you know that that night, that supercell split? Okay. So, the supercell that produced the Howland tornado, here's the left split, here's the right split. The right split is what ends up going and producing the tornado that went through Hallam. The left split is what ended up going between York and then probably north parts of Lincoln. This is pretty crude imagery. I mean, I did this in 2004, but I mean, there's the hook right there. There's Hallam. There's that tornado. And of course, Lincoln is up here. Well, what if that supercell that produced the Hallam tornado didn't split? So, this is October 2006 imagery. Be mindful of that. So what you're looking at here is then, in October 2006, what Lincoln looked like. This is the Hallam tornado, or what was the Hallam tornado, actually entering Lincoln at 27th and Highway 2 and coming up right through the southern part of the city. 7 hospitals are hit, 20 schools are hit, and between then, again, October 2006, 45 to 50,000 people are directly impacted, and you're looking at a total potential, if you go to the extreme, just under $2 billion in damage. So, again, this is why situational awareness with all events are crucial, because it only takes one event. Let's go to June 28th of 2023. This was an event out in Nebraska Panhandle. Same thing, go through the Storm Prediction Center outlook. Slight risk out here, doesn't matter where it's at, same things apply. Outlook says conditions favorable for isolated supercells. Well, isolated supercells and discrete cells are pretty much the exact same thing, just different terminology. Strong to severe outflow gusts and a tornado or two possible, but here is the interesting one. Persistence of storms in the evening is uncertain. Especially if this were to happen here, this is where you start getting into June. June's our peak month here for severe weather. Sometimes, as you get into the evening, the capping becomes a little bit questionable. Is it going to suppress storms? Are the storms going to merge? Are they going to become outflow dominant? Are they going to be able to remain isolated? So there's even the experts are going to be a little bit uncertain about how these storms are going to develop. So you start reading the AFD. Pretty detailed explanation, analysis of this event. Dew points approaching mid-50s at sunrise. For those of you who have been out to western Nebraska, mid-50 dew points, period, feels a little warm, a little moist out there. I use the word again, oh well. So you've got significant 0 to 6 wind shear, expected to be 60 knots with pockets of 70 possible. The threshold for supercells is 35 to 40 knots, 60 to 70. Again, red flag. Here's an interesting site that I use. This is schumacher.atmos.coloradostate.edu. What this does, this is a 4-panel thing. I don't know what the 4th panel is for, but here's your tornado probability, your hail probability, and your wind probability. The black dot is the bullseye, what it thinks is the greatest potential. But what you're looking at here is just what kind of probabilities are they looking at for each of these things to occur. Again, just another tool in your huge toolbox, so just keep that in mind. When you stop at Arunza in Sydney, and it's wall-to-wall people, and then you start looking at tornado shirts and storm chasing shirts, it's like, well, I guess we're in the right place, because everyone's here. MD issued, pretty standard. Again, I was going to say a pretty good chance of a watch being issued. Again, remember the MDs. Now, 349. Here we are, we're 23 miles from the storm. Base right here, still organizing. Pretty good anvil starting to develop. Now, 352. As a spotter, what observations am I making right now? I'm going to show you the last picture. Look at that real carefully. Look at it. Feel it. Let's look at this one. What's some observations?
Rain.
Rain is developing.
High clouds.
high clouds. One thing that I want to emphasize here is always, always look on the horizon for a static point. So something that is not moving. It could be a telephone pole, it could be a mountain range, whatever, or a hill, whatever it might be. Use that as your focal point to determine the storm direction. Notice this thing has now moved to the left of the road. It's further away from this hill right here. This storm is moving south. It's not moving east. It's not moving northeast. It's moving south. So, you see right here on the radar, here's our storm. Here we are. Yep, that sucker is moving south. Here it is. Here's the road. Remember, it was kind of like right here. Now it's over here. Here's the base right here. Yeah, it's moving south. It's called deviant motion. Deviant motion is something that you would not expect the storm to do. And there are times when storms become isolated. They may have motions that you're not expecting. I'm going to have an example that you should all remember here real soon here. Now, here's a time lapse to kind of show you. This is over the course of maybe, I think, 45 minutes. First things you're going to start noticing is the base isolating itself, rain's being pushed out. Here it goes, the anvil, growing, rotating very slowly. You almost kind of see right here, it's actually maybe moving back to like the north a little bit. So again, deviant motion is something to always be aware of in a storm, especially an isolated supercell. Again, you're looking over here to the west-southwest, back towards this area right in here. You can see this kind of striated cloud right here. Can't really tell if there's anything touching down back in here, but this is obviously your area of focus. You got all your rain and hail right here. You got your inflow tail. So this storm is all by itself. It's turning up. You can see right in here that little hook. This is a great view. Unfortunately, for most of us here, we're not going to probably have this view. There's your Mama's clouds. Flanking line / your beaver's tail right there. Rain and hail. Anvil. So big it's actually off the frame of the camera here. Wall cloud right there. Now, a couple minutes later, notice how this structure just keeps evolving. Getting a lot more striated looking. This is the mesocyclone right here. This is where you need to be looking. A few more minutes later, this thing is just completely wrapped up. The mezzo is just wrapping right in there. Wrapping around. Run this time lapse. Storm continues to move kind of like in a south-southeast direction the entire time. Yeah, this was a very interesting storm to be looking at, just for the fact of the motion, and once we were able to get far enough out ahead of it, we just said, you know what, let's just look at it, send in the report. No big deal. We're getting close to the end here. You haven't booed me off the stage yet, so that's always a promising thing. Okay.
We'll boo your computer.
The fund to buy a new computer will be taken at the door if you leave tonight. All donations will be accepted.
And greatly appreciated.
And really appreciated, absolutely. The next investment. All right, so we're done with that. All right, so post-event analysis there. Radar is a great tool, can't rely on it. Be mindful of deviant storm motion. The storm moved basically south-southeast the entire time. The biggest threat to anyone out there is lightning. There is no lightning warning. We had lightning coming out of this storm pretty much up to 20 miles from the center of it. There was actually, we were standing just getting some photographs, doing some reports, and there was a bolt that literally came right out in the field. That storm was 20 miles from us. So just be mindful of lightning, especially coming out of the anvil, the thunderstorm. This is probably some of the more powerful bolts. They're going to come out of that anvil. And the bolt from the blue is what they call it, up to 20 miles from the thunderstorm. Deviant motion also applies to tornadoes. This particular tornado near Cheyenne actually moved in a south-southwest direction. Basically what ended up happening was the outflow from the thunderstorm and the inflow were actually balanced enough that it actually cyclically produced another tornado further up from the storm, and this one was pushed out from the rear flank downdraft. That's why it was moving south-southwest. Again, use an object on the horizon as reference to determine the storm tornado motion. May 9, 2016. Does that date ring a bell with anyone? If you know anyone that filed any hail insurance claims, you probably do. This was the Lincoln storm that didn't want to move. Notice this particular day, we're just in a slight risk, just on the fringes of a slight. There's basically, everything was pointing down towards the south and southern plains, south central United States. Nothing really concerning here. But sure enough, there was that one storm that just kind of sat on top of Lincoln, and oh boy, 2 tornadoes, 4¼ inch hail, 4 to 6 inches of rain. Storm sat stationary for almost 2 hours. Here's the timeline. I actually went back through and I looked through different photos and reports, and just seeing how, like, storm at one point was moving northeast at 20, and then it moved northeast at 15, and then about right here, 4:56, moving southeast at 5, then it's moving southwest at 10, and then it moves northeast again at 15. Your mid-level winds that day were meager. That's why the storm, it just kind of sat there on top of us. I want to say maybe the mid-level winds that day were maybe 5 or 10 miles an hour, so the storm just sat on top of us because there was nothing to steer it away. That was one of the tornadoes. Right there, that's the storm. But yeah, this was a tough day. Some really, really big hail fell. And I mentioned this already about some of the ingredients. They were not to the greatest of magnitude, but they did exceed a lot of times expectations as they progressed. The Lincoln supercell basically just anchored itself to the warm front, and any time a storm will anchor itself to a warm front, all bets are off. So, a couple predictions about 2024. We've already had a significant outbreak of tornadoes in southern Wisconsin on February 8th, but what about the rest of the year? There's a couple contributing factors to severe weather in the plains. Are you in an El Nino, La Nina, or neutral phase? Gulf of Mexico sea surface temperatures and the current drought situation. Right here is an index just showing you what our blue means El Nino, red means La Nina, and then you go back and forth, you oscillate back and forth. These last few months we've been towards a La Nina, but now we're going into more a neutral phase where there's no El Nino or La Nina. So what does that mean for us? Well, we've been in pretty significant drought here for a long time. Look how much that drought has been alleviated across most of the state. Moisture's coming back. Gold star for the person who said moist. That's your word of the day. So, we're transitioning out of El Nino into a more neutral phase. Probably by late April, neutral phase by May, June. Sea surface temperatures across the Gulf of Mexico are looking pretty average to maybe above average. Drought situations being alleviated. Things could be relatively quiet the rest of the month from what I'm seeing, except for maybe this potential we got coming up early next week. I'm thinking the storm activity across here is going to be more normal, but I think there's a big concern for mid-May to mid-June, only because that's when the jet stream is going to make its slow traversion more northward towards us, and I think we're going to be in for a potentially interesting year. I started looking at some of these conditions, looking at what other folks are saying. The conditions you're seeing right now are similar to certain years. 2016, I just showed you what happened in 2016. 1998 was also a decent year in the Midwest and North Central Plains. 1966, if you remember, there was the Topeka, Kansas tornado on June 8th in 1966. Kind of similar to that. And then 2010, and that was a big year here too as well. There were a lot of severe weather events. So again, nothing's definitive. It's just an outlook. It's just personal, thoughts and looking at different analogs. But this could be an interesting year, especially as when we get into May. If you have friends or family that need to be warned of severe weather, there's actually a promotion going on through Midland Radio. If you go to Midland Radio, or Midland USA, excuse me, you can actually use a promo code right there and actually get 25% off of weather radio. So if you've got anyone that's in need of one, or someone says, yeah, you know what, you need to be more aware about when severe weather is occurring, please go ahead and do that. Mother's Day is coming up. Great gifts. Go ahead and do it. Probably help someone, save someone's life. All right, let's go to some images and a movie. Ooh, there's maybe some popcorn still over there. Who knows?
I didn't put it away.
All right, so we got a sundog here earlier this year. From the balcony, it was about minus 8 degrees that particular time I took that photo. Snowflake macro photography. Blue Angels. That was fun. If some of you are into photography, but don't need a big camera or what have you, this little device right here is quite impressive. This called from Zenvo. It actually has a 15 times macro lens that allows you to get real close. Do some great images. And there it is using the wide angle with that. That was from my office there at the Department of Natural Resources. Nice shelf cloud coming in. Finally got out to photograph the sandhill cranes earlier in the year. And we all know this guy. Branched Oak Observatory, if you have any interest or know anyone that just loves astronomy or night sky, it is an incredible experience. So there's the website right there. I know Matt was talking about it a little bit earlier. Definitely spread the word. It's a wonderful place. A lot of people do not know it exists. Okay.
A great night under the stars, no pun intended.
Yeah, exactly. All right, we've reached the point of the program where I have a little announcement to make. Our first time-lapse film, as of 8 o'clock, has been released. So if you go to YouTube and search JRBStorm, or if you're on Facebook and you go to our page, JRBStorm Photography, you can actually look at the video, share it, so forth. However, since you are a wonderful audience, you are a wonderful audience, by the way. I'm not sucking up to you, trust me. I only get 3 of those a year. I'm not wasting one on you guys. No. All right. Now let's make sure this works. Again, donations appreciated. No, just all right, sit back, relax. That's my dad right there.
Big obstruction.
I sure
That's
moved fast.
the first time he's ever storm chased was last summer.
Sure moved fast, I tell you. Good fast.
Yeah, this is an original score. We have a good friend, Tyler Corey, who actually put this together. He, yeah, it's really good. I wish I could get that type of ovation every day. All right. Well, that is everything. Thank you for being a wonderful audience. As always, if I'm lucky enough to come back again next year, I'll see you guys again. Otherwise, it's been great knowing you. All right. Probably a few minutes, maybe less, for a couple questions, concerns, criticism, hopefully more the former than the latter.
Questions?
Yep.
Good.
My wife wants to know if you went to Morley Elementary School.
Do you remember that far back?
I do, but I grew up in East Central Ohio. West Elementary doesn't mean anything to you.
Okay, well, there was a student that was all pumped up about weather and wanted to be a storm chaser. So I told her I would ask.
Oh, no, you're fine. I've been told there was a past job that for some odd reason the person went on a 5-minute thing about I sounded a lot like Dan Aykroyd. I'm like,
Yeah.
okay. Yeah.
Got a question over here.
All right, go ahead.
Right inside.
Over there.
Oh, okay, over there. There you go. There you go. Should have seen you.
As a new spotter, tell me what's the best way to differentiate between actual rotation for tornado or rotation for scud?
Great question. So here's my take on scud versus tornado. There are probably, for every 10 tornado reports out there nowadays, I think probably a good, I don't want to get myself in trouble here, but I would say probably at least half are probably false reports, meaning they're looking at scud and the infamous, you'll hear from a local, someone, you know, when we're out and about, they'll say scud-nado or something like that. Again, you think about the structure of the storm and knowing where that main updraft is and expecting where that wall cloud will be and seeing now, if something's dangling down from there, you have to look at it for a persistent amount of time. If that thing stays there for a good while and you can clearly see it's rotating, and especially the base of the storm is rotating, that's more credence to a funnel. If it just dangles down there and it's goes away, comes back type deal, or if it's hanging out from a different part of the storm that's not associated with wall cloud, scud.
My problem has always been if I'm too close to the storm and I see the scud rotating and I can't see all the structure.
Yeah.
So then it becomes a question.
Watch the ground. If you see, because there's a lot of times the condensation funnel will not be visible. But if you look around the ground, you see some dust being circulated or whatever, that means you probably have a tornado in progress or on the ground, but you don't see the condensation funnel yet. That does happen. That does happen. So if you're super close, watch your horizon. Start seeing if there's anything being kicked up, if it's actually circulating or whatever. If you see a bunch of just everything is straight and you're feeling the wind hitting you, that's outflow. But if you have wind at your back and it's going straight into it, that means you have inflow. That means I give more credence to start seeing some stuff rotating up there, especially near that wall cloud. So again,
the radar scope app will probably help as well.
Correct, yeah.
To identify that.
Correct, absolutely. So again, it's all the tools in the toolbox, as I mentioned right there. Your eyes are the most important thing.
Yes.
But having those other tools and your knowledge and your situational awareness, that takes you to the next level as a spotter.
Thank you.
Yeah.
And remember, when you're reporting on the radio,
Yes.
we don't use the word tornado. We use lowering with rotation. Now, it doesn't become a tornado until you have debris, lowering with rotation and debris. That's when it's on the ground. Other than that, it's a funnel. The reason for that is there's other people out there listening
Oh, absolutely.
to us on the scanner, online, and then you get false reports to the media, you get false reports to NWS, then they sound sirens. We're a part of that group that we see 3 sirens go off. And so,
I think that was June 11th, 2008. I think you were in the basement with Oma and I think Olivia.
Yeah.
And you were hearing reports. This was a storm. There was a storm in Lincoln, and there were reports of a tornado, what, 48 and 0 or something like that?
yeah, I remember.
So somewhere in central Lincoln, it was a false report.
Oh, yeah.
It was a false report.
Yeah.
And then of course, just everyone took it with that without validating it, and that's how
Any
you create-
additional questions? All right, you do.
I've seen scuds before that just keeps rotating, but it's not strong enough quite to be a tornado yet. And
Well, if it's
on-
scud-
There's not enough energy for it to develop any further.
If it's scud, it's likely detached from the
It
structure.
kept circling.
Well, it might be circling, and what they call that, wind shear?
Yeah, so in that particular instance, you may have a situation where the storm may rotate for a bit and then it dies off. You have to have that persistence. Again, so if you really want all of the visual clues, also think about your wind direction too. Do you have sustained winds towards your back, or do you have more winds kind of blowing towards you? If your sustained winds are more towards at your backside, that means that's inflow during the storm, and I would give more credence to anything that may be potentially rotating. If it's outflow and you're feeling cool air hitting you in the face, that may be more indicative that you'll see more scud developing, and that's where you see that. You still may have things swirling up there, but I mean, unless it's very, very pronounced, I wouldn't be as worried unless, again, the wind is at your back.
I've seen the shed go later though too.
Yeah, so, again, the environment, again, things can change real quick, so just be alert. That was one more.
Yeah. One of your earlier slides there, you showed a picture of the clouds in the sky, and you said, this is a severe weather day. You made a comment, but I kind of missed it. What was it you were seeing in the clouds?
So basically, you saw a bunch of like cumulus congestus. So you got your white little puffy cotton ball, those are cumulus. But then when they start all congealing together and all that moisture is coming together, and you see them also tilting with height, now that's indicative of 2 things: your moisture convergence and also your wind shear. So you see those towers that are tilting like that, that means you know you've got your shear as well. So at that point, your severe weather sky, even though it's still blue, is you're probably a couple hours away from things turning into a severe weather day potentially.
One more again. Sometimes you'll see these thunderstorms blow up, these angles, and then nothing ever happens. Is that sin and make sure that blows the tops off?
Potentially. So the anvil is basically, it's hitting basically the area where the air is basically where it cannot rise anymore. So basically you take a parcel of air and you lift it up through the atmosphere, and it's just going to keep going and going and going because it's buoyant, because it's warmer than the air surrounding it. At some point, somewhere in the upper atmosphere, it's going to hit a point where it is now the same temperature as the air surrounding it. That means it spreads out, and that's the anvil. So it's not necessarily sin, because sin is usually closer to probably the lowest, like 1,000 meters, kind of like the lowest, like 1,500 feet or so. That's where you see the majority of the sin. But what you're seeing now, when it fans out there in the anvil, that's basically, it's now reached a part of the atmosphere where it can no longer be buoyant. It could be at different stages, and that could be part of, whether or not you have an actual mature supercell or not. But that's what's happening. That air parcel can no longer rise. Its buoyancy is done, and it fans out into the anvil.
That's good.
Just, there's your education right there.
All right.
All right, thanks again.
Very good. Well, Jeremy, I'd like to offer March or April, depending upon when we have our storm spotter training,
to ask you to come back.
I always say leave it to the people. Want me back again?
Yeah! All right, the people have spoken. Again, donations at the door for new computer.
As long as it's not a Mac.
Okay, well, okay, well, make it an exception.
Thank you,